Hello, my name is Kelsey from SimQ. Today, I will present our SimQ VIT software for virtual implant testing. Let me show you how SimQ VIT assists in verification, strength assessment, and safety of patient-specific implants. To start, we click the desktop SimQ icon to open the software. We can now set up highly complex biomechanical simulations for each patient within minutes. Let's open our mandible reconstruction workflow. To set up a simulation, we import the bone, bone graft, implant, and screw STL files. Choose the material for the implant and screws. Different materials are implemented in our library, and of course, more can be added according to customer needs. Next, set the landmarks to register the patient-specific geometry to a known reference model. All the landmarks are labeled anatomically, and a step-by-step guide is pictured on the right. Once the landmarks are set, click Register, and a transparent overlay will appear. This overlay represents the known reference model and should adequately cover the patient-specific geometries as shown on the screen. Once verified, now choose a load case from a predefined selection. These are also customizable according to customer needs. Here, the user can change the load case position by simply moving the main force arrow. As it is a biomechanical simulation, we have also implemented support and muscle and joint reaction forces from a musculoskeletal model. In this workflow, the support is shown by a blue 3D fixed bearing and the muscle and joint reaction forces by gray spheres. Now, we save the project and send it for simulation. Projects are sent to the cloud and calculated. Results can be retrieved within 5 to 45 minutes depending on structure complexity. We retrieve it from the calculation server to see 8 results. The first result, material limit exceeded. This is represented by a 2-color scale, green and red. Here, the user can easily see the areas in green that are below the material limit and the areas in red that are above the material limit. Number 2, total deformation. This result is represented by the more colorful scale and shows a deformation both in location and how much in millimeters, independent of force direction. Number 3, normalized strain of the bone. This result shows the areas in which the bone is under high strain. This means that a higher force is transferred to these areas. Areas around the screw holes should be particularly observed. Number 4, shear stress of the implant. When a force acts parallel to the surface of an object, it exerts a shear stress. So when this is high, the material could be damaged due to shearing forces. Number 5, tension stress of the implant. This force should be considered because different forces pull on the material of the implant. Number 6, von Mises stress of the implant. This is a mix of tension, shear, compression, bending, and torsion stresses into one, considering a mix of all stresses in the implant material. Number 7, screw force direction, screw to implant. When a patient bites down, the screws must hold the patient implant in place. In order to hold the implant in place, the screw must exert force on the implant. The arrows point in the direction of that force through the implant and into the bone. Number 8, screw forces, implant to screw. These values are from 0 to a maximum. There's no material limit here, but the screws are colored according to the forces. The designer can observe the colors of the screws and the force direction with this result. Now that all the results are reviewed and the implant design is finalized, you can save an implant-specific report for technical documentation and QM systems. SimQ VIT easily creates this report with a few clicks, saving time and valuable resources. Our basic simulation report is available to all customers with any SimQ VIT subscription. We also offer FDA-compliant reporting, which is always up to date and based on the latest published FDA guidelines. In summary, the workflows implemented in SimQ VIT software provide a robust, reliable, and fast solution for the assessment of mechanical stability of patient-specific implants. The results of patient-specific simulations can be utilized by medical device manufacturers and medical professionals alike to improve the implant designs and avoid implant failure. Workflows for other anatomical regions can also be implemented together with customers. Stay ahead of the competition and benefit from our new innovative software, SimQ VIT. We look forward to hearing from you.
SimQ, we personalize patient care with simulation.